Conference, your source for JVM knowledge.
So, welcome to this talk about Struts 1 and Java 1.6. I think that you are going to enjoy this talk. Now, welcome to this talk about GRAALVM with Kotlin and Groovy. First of all, let me introduce myself. I'm Alberto de Avila. You have my Twitter account right on the bottom of each slide. So if you want to say something, feel free to write on Twitter. I'm team lead at Salenda. I'm Groovy Rails developer since, I don't know, 8 years, more or less. And I am also Atlassian certified. For those who don't know anything about Salenda, Salenda is a software company based here in Madrid. You may also know our CEO, Alvaro Sánchez Mariscal, that is one of the Rails and MicroNote team, and is the author of the Spring Security REST plugin for Rails. We are mainly dedicated to the software development, so if you need some help with this or Atlassian tools like Jira or Bitbucket, come to our stand and say hello, and let's talk about those topics. So let's start this talk. First, I want to say something about GRAALVM. Be careful. If you want to use, you have to test it very well, because it's under development right now. I think it's very, very close to go to production, but not yet. What are the goals of this talk? We are going to see how to increase the JVM performance. We will see, I think, the most promised thing in the future of JVM. How can we do with programming languages, with multiple programming languages? And so a little about system independence and serverless. What are we going to see? We are going to see what's GRAALVM and what are the features. We will see some pieces of code with Groovy and Kotlin showing how it works with GRAALVM. What are the limits using GRAALVM with Kotlin and Groovy? And my personal opinion about the future of GRAALVM. So let's launch a rocket called GRAALVM. But before I start talking about what's GRAALVM, let's talk about what's Graal. Graal is a dynamic just-in-time compiler that improves efficiency and speed. But what is that just-in-time? Just-in-time, or a just-in-time compiler, it's a piece of or a mechanism that transforms bytecode to the machine code. So this is a typical picture in a talk about GRAALVM. We have here the current compiler for the JVM, the C2 compiler, that transforms the Java or Scala files or classes into binary code. But here in that image, we have two new pieces. We have the JVM CI, the JVM compiler interface, and a new compiler like, for example, Graal. And this is the GRAALVM architecture. Let's look at where is the Graal compiler located. It's in the bottom of, in the top of the JVM compiler interface, and it's executed in the Java hotspot VM. Later, we will cover what is Truffle and how can all this language works with GRAALVM. So once we have seen what is Graal, let's see what's GRAALVM. GRAALVM is an ecosystem and a shared runtime offering performance advantages to multiple languages. Let's explain a little about each bold word. It's an ecosystem because with GRAALVM we can execute a whole of application in different languages. We have also multiple languages because GRAALVMs provide us an API to make interoperate each other. It offers a good performance, mainly because they use a new compiler, the GRAAL compiler, that make better performance, make better improvements at the language level, and because they can generate native images. So, with GRAALVM, we have all of these languages that can generate a GRAALVM output that can be, for example, an Java application used with OpenJDK, or even a Node application. The most popular thing using GRAALVM, the standalone images, but we can also generate code to put inside our database, like Oracle or MySQL. So, what language support GRAALVM? It natively supports, of course, JVM languages like Groovy, Kotlin, Java, Scala, etc. But you can also execute LLVM languages like C or C++ and JavaScript. If you want to execute another languages like Ruby, Python, or R, you have to install inside your GRAALVM distribution another packages. When you download the GRAALVM installer or source, it contains four things. It contains the Graal, the Git compiler. It contains also the Graal Polyglot API that allow us to combine all the previous programming languages to work together. You can use the Graal SDK that is used to configure native image and embedding Graal. And you have also the Oracle Hotspot JVM. License, another important thing here. We have two licenses, the Community Edition for free to use, and the Enterprise Edition with the Oracle support. GRAALVM was a research project from Oracle, but now is really close to be ready for production. We don't know if in the future Oracles want to earn some money with the use of GRAALVM, but for the moment are the same version. What features do we have? With the use of GRAALVM, we can, as I said before, we can interpret with other programming languages, and a cool feature that it contains is with the installation of GRAALVM, it includes some consoles. So you have you can type in your terminal only JS, and it brings up a console to program some little code in JavaScript or R, for example. You can create compiled native images. You can run code faster and efficiency, and it includes some tools to monitor, debug, or profile your code. Let's see one by one. How can GRAALVM make interoperate multiple programming languages? The answer is Truffle. But what is Truffle? Truffle is a framework. It's a framework that allows us to create language interpreters. It is based on annotation and ASTs, and it contains the common themes across any language. Let's review the architecture of GRAALVM. In this picture, you can see that Truffle is in the top of Graal compiler. Truffle enables us to create new interpreters. So you have here some examples of new languages that can be executed in an image, for example. But maybe in the future we will come more languages. Let's see an example, because we are developers and we want to see code to understand the things. As you can see in this piece of code, this is a Java class, very easy to understand, that has a main method, and we are creating a list in JavaScript in that line. So we are creating a list with 4 values, and with the Polyglot API, we can get in Java the value of a variable in JavaScript. We have only have to call the Polyglot API and say call the eval method. So let's see another example using Python. The only thing that here is changing are 2 things. First one, the first line, the way to initialize the context, and the second one is only the programming language name. Let's see a third example. The Ruby example is the same that in JavaScript and Python. The only thing that changed another time is the way to initialize the context. But let's see a more rich example. This is a Node application that can be executed with Graal that use a piece of code in R that can generate a graph like that. As you can see, there are many possibilities using the Polyglot API. So we can dedicate our application to each task in different languages. So, as I said, we use the appropriate languages for any task. For example, if you want to process big data, use some language. Or if you want a library from another language like, I don't know, Python or Ruby, you can use it with Graal. You can create a single app combining multiple languages. And one of the good things using GRAALVM, you can have only one environment for all your requirements. If you download GRAALVM, you will have, by default, Node install, Java, JavaScript, etc. Let's talk about I think the most popular feature about GRAALVM, the native images. A native image is a self-contained executable with a fast startup and a low memory consumption. And how can we do with that? We can generate, for example, a binary library, or use it in lambdas, containers, or even in the command line. GRAALVM can generate native images, but not yet cross-platform. This means that if we generate an image, for example, in Linux, it will not work in Mac. For Windows users, call Oracle to request support. If we talk about native image, we have to talk about ahead-of-time compilation. What does it mean? The ahead-of-time compilation is to pre-compile our code before start executing it. It analyzes statically all of our code. It compiles only the reachable, because the code that is not reachable, it will not be compiled. So be careful with that. Then it generates the native code, and it is packaged with a substrate VM. Another name here in this talk with a lot of names. What's substrate VM? It's a subset framework of the JVM. It has no JIT, no optimization, and no Graal. It contains only the things for the runtime. It contains things for the garbage collector, the threads, input and output, etc. He has a tweet from one of the engineers working in the Graal team. He said that they have created a Java agent to generate some config files to help the developers to run GRAALVM native images. Later we will see how can we help us at the time to generate a native image correctly. Let's talk about the performance, one of the other common thing in GRAALVM. It depends on two things: code optimizations, because of the new compiler, and the use of native image. As I said before, we have native image with a very, very fast startup. For example, a little application can start up in, I don't know, 30 milliseconds or something like that. But be careful, because each language has different performance. Let's see. This is an Oracle graph from its documentation. I think it has some time, but it can show you. First of all, I want to say that the red bars are for the Graal, if you can see well, and if the bars are higher, are better. As you can see, for Java and Scala, it has more or less the same performance. For Scala, is 20% better in performance way. But in Ruby or R, we have 4 times faster execution. And this is a good example of what Graal can do in real life. This is a graph from the presentation of Crystal Langier or something in the Twitter engineer team, that it was explaining that they are using Graal on production ready now, but they are obtaining more than 10% of better performance than using JDK 9. So with this, they have saved more than $5 million in computers only using Graal. So a 10% can look like only a little, but it can represent a lot of money in big companies. But you have to be careful, because Twitter has a team dedicated only to work with GRAALVM and to make it work well with all his code. So be careful. Tools. This is a thing that not many people knows about GRAALVM. With GRAALVM, you can use the debugger from, for example, the Chrome Dev tool to debug code in another languages than HTML or JavaScript. We can, for example, debug Ruby code or Java code or some others. And we can use a tool in the Java framework like VisualVM using a Ruby application. In this screenshot, you can see a Fitzbuzz problem writing in Ruby, and with the Chrome Dev tool. And this is, I think, a good feature, because you don't need any IDE or any other tool to debug easily in a computer. Or for example, with Ruby, that is difficult to profile an application, you can use a better tool to get some information about your application. But let's stop about the theory. Let's see some code. Before, I want to show you how to install GRAALVM on your computers. You can download it manually. but I don't recommend you to use that way. I want to use two ways, the SDK main and the Docker image. How many of you use SDK main? Well. The people that doesn't raise their hand is sleeping. Okay. For those who don't know what is SDK main, a little pieces, you can install that SDK manager with that sentence, and to use GRAALVM, you have only to write in your terminal SDK install Java and the version that you want to use. For example, I put RC11, but I think they has the latest version. So let's see a simple problem like factorial. And how can we solve with Groovy and Kotlin? The first way I try to solve this problem is using a Groovy class. As you can see, this Groovy class has a main method that receives by parameter a number, and if the thing received is a number, it calculates the factorial and prints by console. As you can see, it's a very, very easy code. The other way to get this work is using a Groovy script that is very, very similar to the previous one, but the only thing that is changing here is the way to use the args. So to use that, we have to call the getProperty method, and we will have access to the args. But this is, well, will you get? When you try to execute the previous code with a Groovy, you will get works perfectly. But if you try to generate an image with GRAALVM, or if you try to execute the Graal image, if you get the image working, you will get some exceptions like that. So let's see how can we fix that exceptions. You need to configure two files. This is the first is optional. You have to write the compiler.groovy if you want to write the annotations for your Groovy files. You have to write to put the compiler static annotation. But if you want to, you can write in the top of your Groovy file. And you have another file, the reflect.json. The reflect.json contains some information about all the meta methods needed to execute the Groovy code. I don't know if you can see, but here we have a name, a very, very strange name, like Groovy runtime DMH, I don't know, 193. These are meta methods that my Groovy file uses, and I don't know what is this number, but we need to put there in this file to make it work.
Is it that same exact number every time? Or is it
No, because it depends on this is the number that you have to write. I don't know because why is this number, but
you have to make it fail and then
yeah, you have to write it. But as I said before, there are some tools that helps to do that automatically. For example, the Java agent, or for example, the MicroNote team has do a big work to make it automatically. So once we have those two files, the compiler.groovy and the reflect.json, we can first of all compile our Groovy code using Groovy C and the compiler.groovy and our file. And then we have our class compiled, or our script, Groovy script compiled. We have to generate the image. This is what it looks like to generate Groovy native image with Graal. we use some config that I don't know what this means, so don't understand about that. Maybe the people expert than me here in the room can answer, but the important things that has here are two things. You have to include the jar of Groovy to execute inside the image, and you have to put the reflect.json to show to indicate where are the reflection configuration, and in the last argument the name of the class file. Before change to Kotlin language, then once you have that, it generates an executable, and you can execute it very easily. Later we will see an example how to execute it. How can we do this with Kotlin? I think it's easier than Groovy way. The code example is the same with the syntax in Kotlin. So when we want to compile our code, we have to call the Kotlin C, passing the factorial class, and generating a jar file. Generating the jar file allows us to generate easily the native image. So we can call the native image and send in the jar name, and it will generate our native image of that Kotlin code. And another cool thing, using MicroNote with GRAALVM. You can generate native images from MicroNote. But be careful, because only Java and Kotlin are fully supported. The Groovy are partially, so be careful. MicroNote includes a script and a Docker file to generate the image. I think that in the latest version it only includes the Docker file. I don't know if it's correct, Ivan? Yes? Okay. But this is the release candidate. In the current version, I think it included two options. And as I said before, it can generate automatically the reflect.json. Let's see a real example. First of all, you have to create the MicroNote application, specifying two things, the two profiles, the native image profile and the Kotlin profile in this case. Once we have that, we have to create only a controller, the factorial controller, annotated with the controller annotation and the path for the controller, and we create an endpoint to calculate the factorial. This is not important. Let's see what's important here to generate the image. So, to generate our image, we can call the script including MicroNote, the build native image, and when we have the image to execute it, we have the option to put to execute the grid example. And if you look well, I don't know if you can see it, but it's running in 32 milliseconds. It's really fast, really, not the Spring Boot, as we said. What about limitations? You have to evaluate statically the code at compile time, so be careful. If you have a code with, for example, a constant with a new date, be careful because it will fill with the date of the compilation time, not the runtime. So be careful with the use of static variables. You cannot use dynamic code. So Groovy, you are in trouble. You will have some strange exceptions. because as we saw before, but not only these ones. For example, in a project that I was working with a MicroNote application written in Kotlin, it has a different behavior between the runtime and the native image runtime. So be careful with that. Yeah, another two limitations. It takes a long time to generate the executable. I have seen on the internet that some medium or large projects take until 60 minutes to generate an image. So this is long time. And be careful, it only works in Mac or Linux and 64 bits. Sorry, I forgot to say that these limitations are related to the native image. The use of GRAALVM as a SDK, I think that doesn't contain many problems. Maybe some bugs, but you can use without that limitations. Let's see the limitations in Kotlin with GRAALVM. Almost all the features work with Kotlin because Kotlin is an static language, and almost all the features can be done with Graal. I have to say that there are some bugs or features that doesn't work currently. For example, it does not support a compilation of non-reducible loops, and another few things that doesn't work for the moment. If you want to see what feature doesn't work at the moment, you can see, look at the GitHub project of Graal and see and look for Kotlin bugs. This is the important thing, Groovy. For make Groovy work with GRAALVM, you have to make some rewrite of your code or make a lot of change to work with your code in a native image. You can even not use metaprogramming. The use of closures requires some manual config, or some exception you will get. And grape doesn't work with the native images. So I think there are important features that we are losing here using Groovy with GRAALVM. Another example about that, this is a Groovy code that generates a random number and works with it with some methods. With this int stream, the problem at the time to use this code with GRAALVM is that when he tried to use the map method, he's using a closure, and you need to specify a file like reflect.json with some config to work well. This is a more or less complete list about the features that are supported or partially supported or not supported at the time to use native images. For example, finalizers, you cannot use it with native images. Or for example, static initializers. It is only partially supported. So if you want to read more, you have to go to the Substrate VM project and read it very well to know if you can use it in your projects. Let me give you my impressions about the GRAALVM. I think that more languages and tools will be available to use with GRAALVM. We will see in a short future a single app or a microservice app using many languages working together, and we will have to learn some other languages for those reasons. I think the Oracle team is working to make a native image compatible with all operative systems, because they have the issue open on GitHub. And I think that we will have a better performance using GRAALVM, because the project was created in, I think, 2008, but now it's gaining more popularity, and I think they will work on increase the performance on each language. So we are going to finish. Here you have some links about documentation, repos, blogs, and talks about GRAALVM. So if you want to learn a little more about that topic, you can visit its links, and it will be very useful. And I think we have 5 or 10 minutes for questions, so thank you very much for coming. Sergio is not here, so I will be.
Questions?
Come on. No questions? This is the conference of no questions? One question.
So
Wait. It's for the video camera, not for me.
does MicroNote help? You mentioned with closures. Does it help kind of resolve and generate the necessary
I don't know.
JSON file?
This is for you, the question.
We're not doing anything special. We're not doing anything special for Groovy at the moment in MicroNote. What MicroNote does is it eliminates at the framework level dynamic class loading, reflection, runtime proxies, and all the different things that make it complicated to work on Graal. However, it definitely works better if you stick with Java at the moment. What we're also doing is we have logic in MicroNote 1.1 that computes the reflection necessary, that is still necessary for third-party frameworks at compilation time by generating the necessary reflection data. And that does so using a type element visitor, essentially, that visits your code and figures out what needs reflection for when you're using like third-party code like Jackson to serialize objects to JSON or anything like that that requires reflection. So we compute that all ahead of time. But we're not doing anything special for Groovy yet. It may be possible to do that for Groovy, but as we saw, the closure names are like seemingly random numbers. Well, not random. They're not random. They're sequential, but it's hard to figure out in the source code what the names of those are. Having said that, in Groovy 3, when it comes out, which hopefully is on the horizon, supports native lambdas syntax instead of closures. So you may be able to do more with Groovy 3. By it's progressing. I think it's in alpha at the moment. But basically, with Groovy 3, if you stick to the native lambda syntax, it's going to generate native lambda bytecode and not closures, which you could do in GRAALVM to not have these problems, for example. So that's a little way off.
Perfect answer. Nothing to say. Nothing more to say. Any other question? No? Yes? One more.
Everything I've heard about Graal is always oriented to server-side development, okay? But I don't know, but maybe where it can really make the difference is in client-side applications. I don't know if you have read something about someone thinking on that, or?
No, I have no. Many of the blogs that I have read and the talks are oriented like a view here. So I don't know if it has better features that will come for that. So I don't know. Maybe in the future they will include something.
Maybe Swing is going to be mainstream again. Thank you.
Any other question? No? It's coffee time, so come on.